Hello and welcome to Lockdown Mathematics. Today we're going to be looking at some more calculus, and so today for today's topic we're going to be looking at tangent lines. We're going to try and look at some cubic functions and try and understand it and apply this in your mathematics for your exams. Okay, so to start off this lesson, we're going to be looking at the equation of a tangent to a curve. Okay, so basically a tangent, just one second. Okay, there we go. So basically a tangent is any point that touches or intercepts the curve once and forms a 90-degree angle. Okay, one thing you need to know about these tangents are that suppose I got a line here and my tangent is this horizontal line that I drew here. One thing you need to know is that the product of their gradients is equals to -1. So m1 times m2, their slopes must give you -1. And so we're going to use some differential equations and calculus to solve the equation of this straight line that we got here, this tangent line. Okay, we want to know what that equation is. Because it's a straight line, it must have the form y equals mx plus c. Okay, and so that's what we're going to be looking at now. Okay, so the derivative basically defines the slope of a curve at any particular point. So if I sub in some point or some constant c, I can get the actual value of that slope m by calculating the derivative of that function. So to determine the equation of a tangent to a curve, it's very simple. You're going to first find derivative using rules of differentiation. You'll substitute the x coordinate of the given point, right, to calculate the slope of the tangent. The next step you take in step 3 is to substitute the gradient of the tangent and the coordinates of the given point into an appropriate straight line equation. So I'll show you how to do that in an example. And lastly, making y subject of the formula from this straight line equation. Okay. Okay, reiterating that the gradient of a tangent and the gradient of the normal is -1. And normal means they form a 90-degree angle when they intersect. Okay, let's look at an example. The question states here, find the equation of a tangent to a curve. So find the equation of the tangent to the curve y is equal to 3x squared at some point 1 and 3, where x is equals to 1 and y is equals to 3. And they say sketch the curve and tangent. Let's not worry about that. Let's worry about the mechanics or the mathematics behind this problem. So the first thing we're going to do is we're going to find the derivative. The derivative of y equals 3x squared will be 3 times 2 x to the power 2 minus 1, which is essentially 6x. Right. Now we're going to substitute our given point. Our given point is 1 and 3. Okay. And so when I substitute x equals 1 into the equation, I get 6, and that is my slope. So whenever you find the equation of a straight line, you know it's y equals mx plus c. And so we got the gradient. You just need a gradient and the point to solve the equation of a straight line. So we got the gradient, and the next thing we're going to do is we're going to solve for c using this equation, the equation of the slope. And that is coming from gradient is equals to y minus y1 divided by x minus x1. That's how we get this equation. So what we're going to do now is we're going to substitute the point, given point 3 and our given point 1. We already got the slope being 6. And so rearranging the formula and solving for y, taking 3 across becomes plus 3. 6 times x gives you 6x, and 6 times minus 1 is minus 6. So your overall equation is 6x minus 6 plus 3 gives me minus 3, and this will be my equation. Alright, so you got an increasing slope. And that's why this line here increases. Okay. So it's very easy. If they tell you to sketch it, y equals 3x squared is a parabola, so you can sketch a parabola, and then you can draw your tangent line at the point 1 and 3. So you're going here, 1 and 3, and the point where it's by the parabola is where you will extend your straight line. Okay. So that's a fairly simple problem. Let's look at another question to familiarize ourselves and get more comfortable. Find the equation of a tangent to a curve again. And this time we got g of x and we got x plus 2, 2x plus 1 all around squared. And this time they just gave us x equals plus 1. Okay, now you could tell me I don't have a point. I just got the x coordinate. Well, you can get your point. You can get your y point by simply subbing x into the original equation to get your corresponding y. Okay, and so if I do that, if I substitute minus 1 into this bracket, then what I'm going to get here is 1. And if I substitute minus 1 here, I'll get minus 2 plus 1, and that would give me minus 1. Minus 1 squared is 1, and 1 times 1 is 1. And therefore, my x-coordinate is minus 1, and my y-coordinate is positive 1. Right? The negative disappears because of the squared. Okay, so let's move on. Determine the y-coordinate of the point. So that's exactly what we did. We got our corresponding point. And so now we're going to find the derivative after we simplify. So in my earlier notes on calculus, I said you cannot find the derivative without multiplying and FOILing everything out. Multiplication and division does not warrant division. We want addition or subtraction between our variables, then we can find derivatives. So here we got x plus 2 and here you got 2x plus 1. The first step here would be to FOIL out this bracket here. So 2x times 2x is 4x squared. 2x times 1 is 2x. 1 plus times 2x is 2x. 2x plus 2x gives me 4x. 1 times 1 will give me 1. So that's how I'll get that bracket. The next thing you're going to do is you're going to multiply x plus 2 to each term here. And you'll get this very lovely looking set of variables. And you're going to group your squared terms, group your x terms, group your cube terms, and see what that gives you. There's only 4x cubed, so 4x cubed remains the same. In terms of squares, I see a 8, I see a 4, that gives me 12x squared. In terms of x, I see a x and a 8, that gives me 9, and I got 2. So differentiating this is pretty simple. You're going to get an answer of 12x squared plus 24x plus 9. But I need the slope at some x value, and we know that x value being minus 1. If I go down and substitute minus 1 into this equation, I will get my slope, and that is minus 3. So now in my equation, y equals mx plus c. I've got my m, I need c. And so I'll substitute any point in 1 and minus 1 and 1, and my equation of straight line results in minus 3x minus 2, and you can sketch that, right? Okay, so now we're going to just kick it up a notch. It's a little bit different, but not hard. It's very easy. We're just going to find the normal to a curve now, the equation of the normal. So if you know the tangent equation, you can get the equation of the normal line. So here we go. Here, my normal line being this line here. So if I know the equation of this line, I can get my normal. So we got x times y is minus 4 at minus 1 and 4. So what I need to do is I need to make y subject of the formula. In this case, I'm going to get y equals minus 4 divided by x. But I always told you guys that whenever you're dealing with a fraction and x is at the bottom, you write it in exponential as an exponent, which is minus 4x to the minus 1. So now I can find derivative. Minus 1 times minus 4 is positive 4x, and minus 1 is minus 2. But I always said to try and write it as a positive exponent. So you're going to get 4 over x squared. Alright, so let's keep going. Next thing is we can determine the gradient of the tangent at the given point minus 1 and 4. And so if I substitute that into 4 over x squared, I'm going to get 4 divided by minus 1 squared, which is 4 divided by positive 1, which gives me 4. Now we know that the slope normal times the tangent is equals to minus 1. So just as a rule of thumb, what you should do is once you got the gradient of your tangent, to get the normal slope, you're just going to flip your fraction and times it by minus 1. So 4 over 1 becomes 1 over 4, but times it by minus 1 makes it minus 1 over 4. And so now I've got the gradient of my normal line. I got a point on my normal line. I can find the equation of my normal line. And so that's exactly what I did. That's exactly what I'm going to do here. And your final equation will be minus 1 over 4x plus 15 over 4. Okay, so looking here, you can see that the original function is a hyperbola, and so you can see it intercepts with the second quadrant hyperbola of your rectangular hyperbola. Okay. So moving on, we're going to be talking about second derivative. Basically what the second derivative is, so suppose I got some function equals to y equals x cubed. Okay, to find the derivative of that, which is y prime, I'm just going to take normal derivative, and that gives me 3x squared. But then supposing now I want to find the double derivative, the second derivative, y double prime. Then I'm just going to find derivative again, and that's how simple it is. 3 times 2 is 6, 2 minus 1 is 1, so 6x is my answer. So the second derivative of any function is the derivative of the first derivative, right? And this indicates the change in gradient of the original function, right? Okay, and so this is the general form that defines a second order derivative, right? And these are some of the notations they use: d by dx of dy by dx, or d squared y over dx squared. So if you notice that, please remember that means double derivative. Okay, so let's find some double derivatives. We're going to tackle them here, right? So let's look at question 1. Pretty simple, straightforward, no division or multiplication. And so this becomes, so if I want to get k prime is going to give me 2 times 3 is 6x squared, which is 3 minus 1, that's how you get squared, minus 8x to the power 1, because 2 minus 1, and derivative of any constant is 0. Okay, so if I want to get k double prime, that's going to give me 6 times 2 is 12x, and derivative of any constant times x is just that constant, the number that is in front of it, right? X is what I'm referring to, not x squared, not x cubed. It has to just be x for it to be the constant. Okay, so let's look at the second problem. Second problem is 3 over x. So I told you that whenever you deal with this type of problems, you're going to put y equals 3x to the minus 1 is the new form that we're going to write in terms of an exponent. You find y prime minus 1 times 3 gives me minus 3x to the power minus 2, because minus 1 is minus 2. But I want this as a positive exponent, so I'm going to rewrite my coefficient on the top, and I'm just going to write x squared at the bottom, and the negative falls away from the exponent. And then you can see that here. Finding the second derivative is done similarly. Let's look at this part here. So y double prime is equals to minus 3 times minus 2 gives me positive 6x to the minus 3. Writing as a positive exponent is 6 over x cubed. Okay. Alright, here's some nice examples or homework exercises that you can tackle. Right, I would really like for my students to please try these at home. And what they can do is, if you're having any problems, post it in the comment section, and I'll be happy to solve these problems for you, or type a solution, or email you a response, or do a video if I have enough people with a common question. Okay. And so just to head start the next video that I'll be releasing, and that is the cubic function, right? And the cubic function is defined by the form y is equals to ax cubed plus bx squared plus cx plus d. Okay, and so I hope this video was helpful. The next video will be cubic functions and how to solve those equations, solve the equation for cubic functions, how to find its turning point, how to find its point of inflection. And so we're going to tackle it, and it's a really nice section. I encourage students to make this their strong point, because it's a lot of marks. You can get very good marks whether you consider yourself weak or strong. If you manage to understand this and you do enough problems, I'm pretty positive that you would be successful and do very, very well in this section. So until next time, drop a like, drop a subscribe. Subscribe because whenever you subscribe, you'll get new notifications of when I post new videos, and you'll get content much more quicker that way, and it's easier to keep in touch with my students. So until then, good luck with your studies and goodbye.